perform some task. For example, printf. What is the use of the printf? The printf use is used to print data on screen. Will you accept this statement? Printf function mainly used to print the data on the screen, on the monitor. I hope you might have heard another function called scanf. Have you heard this name? Scanf? Anybody heard this function name scanf? Yes. What is the use of this? Used to scan. Scan means get the data from keyboard. Like this, I hope some of you may know learn about strlen for finding the length of given string. Like this, our GCC compiler supports so many functions. Those are called as all the above functions are called as predefined functions. What is the meaning of predefined? What is the meaning of predefined? Already defined. Will you agree? Somebody might have implemented, just a minute, will you agree? Somebody might have implemented printf function. How the printf internally communicates with the monitor. Somebody might have implemented the scanf. How the scanf will collect the data from the keyboard. All those are which are not implemented by us, which is already present, already defined. Those are called as a predefined functions. Already called as a predefined functions. And one thing I told you, whenever there is a term called functions, you need to think about 3 points. Again, whenever there is a term called functions, any programming language point of view, in any language point of view, you need to think about 3 points. What is the point number 1? You need to think about the 3 points. One is function declaration. Declaration is also called as a function prototype. Function declaration. Second one is function definition. Second one is function body. Function definition or function body. Third one is function call. No matter is it a predefined function or is it a user defined function, whenever you think about any programming language, especially when you go for a C language, especially the building blocks of the C program is the functions. Whenever you are thinking about the functions, there are 3 most important points you need to think. One is function prototype declaration, one is function body, function definition, and another one is a function call. And third very important rule is before calling function, just a minute, before calling the function, it should be declared above. Before calling the function, The function must and should be declared above. I don't know. Those who already knows the C program, I'll ask a very basic thing about that. Suppose if I'm writing the C program, suppose if I take an example, void main printf, enter the numbers. Suppose just take very basic example program, scanf percentile d. Don't worry, what is this percentile d? All the things, ampersand of I, comma, ampersand of j. K is equals to I plus j. Just adding of two numbers, percentile d slash n, comma k. Can anybody tell me if suppose if I might have compiled this program like this only? If you might have compiled this program like this, my compiler generates an error saying that I and j is not declared it. I and j and k also I didn't declare it. Will you agree? Why? Because whenever you are using any variable as per the C language, as per the C procedure, whenever you are using any variable, they must and should be declared it. Int I comma j comma k. Now you tell me, if I write this statement, will the compiler generates any error? If suppose if I might have written this statement, no. Can I say these are the variable declarations? Can I say this is a variable declarations? Meaning is you're informing to the compiler that I, j, k are which data type? Integer type. I, j, k are which type? Integer type. If you might have not declared this, will you agree the compiler might have generated an error? Now tell me, now am I talking about the variables or am I talking about the function? Now tell me, am I talking about the variables or am I talking about the function? Variables. But when you go for this program, will you agree I didn't declare any variables? But when you go for this program, I didn't declare any variables. Yes. I'm talking about here. Am I talking here functions or variables? Will you agree I'm talking here functions? Will you agree? Okay. Now tell me, who is calling which function? Main is calling the printf function. Can I say line number 5 is a function call? As per the C standards, whenever you are calling any function, it must and should be, as per the C procedure, whenever you are calling any function, it must and should be declared above. It must and should be prototyped above. Getting the point? As per the C procedure, whenever you are calling the function, it must and should be declared above. That's what I'm trying to explain you. Observe this point. The rule is, before calling the function, it should be declared above, like a variable. Before using the variable, it must and should declare it. Similarly, the same rule is applicable to the functions also. Before calling the function, it must and should be declared it. Now you tell me, all this printf scanf function declarations, where it is present? All this printf scanf declarations, where it is present? Answer is header files. Answer is header files. That is the reason I am including the header file above the, that is the reason I am including the header file above the, can you tell me, above the main? Now you may get a doubt that, sir, in a last lecture, if I don't include the header file, above, observe, I'm not included the header file, right? I'm not included the header file. Even though I'm not included the header file, my program gets compiled. Even though I'm not included the header file, my program gets compiled it. But warning came. Will you agree? But warning came. But executable file is created or not? Answer is executable file is created. What if we include the header file after the main? Observe, your friend question is, what if we include the header file after the main? Let's see. Now I'll remove this a dot out. Now tell me, in the present working directory, will you agree only hello.c is there? In a present working directory, will you agree only hello.c is there? Huh? And when I compile this program, see, warning came. Why warning came? Because as per the C standard, before calling any function, it must and should be, before calling any function, it must and should be declared above. Before calling any function, it must and should be declared above. But now you tell me, yeah, am I declaring above or below? In this header file, prototypes are there below. So that is the reason compiler still shown the warning. And in the last lecture, I asked you one question. Is this same rule is applicable for Turbo C compiler or other compilers? Answer we got. In a Turbo C compiler, if you don't include the header file, we may get an error, not a warning. In our GCC compiler, listen the statement very carefully. In our GCC compiler, for this basic hello world code, if you don't include the header file also, my compiler is accepting me by generating the warning. Again, our GCC compiler for this basic hello world program, for this basic hello world program, if I don't include the header file also, my compiler is accepting by showing, warning. But is the same thing can be applicable for other compilers also? Means answer is may not be. And also I told you, in our GCC compiler also, when we go for advanced C programming, we must and should include the header files. Otherwise, instead of warning, we will get error also. For this basic hello world program, no problem at all. So why we are sticking to GCC compiler? Can we use any other compiler? One of the question I got from H3, why we are sticking to GCC compiler? Can we use other compilers? Answer is yes, you can use other compilers also. But if you want to work on the Linux environment, you need to go for a GCC compiler. Again, if you want to work on the Linux environment, if you want to develop code, system level, kernel level code, if you want to develop it, device driver level code, you need to implement it. You need to work on the GCC environment only. Got the point? Got the point? Because all of you might have worked in Turbo C environment. All of you might have worked in Dev C environment or Dev CPP environment. But when you go for current trend, all of the companies are going to shift it into Linux environment. Why Linux environment? Linux is a free source code. Linux can be ported into different hardware architectures. Nowadays, all the embedded products are coming with inbuilt OS, with a free OS, Linux OS. So You must and should work on this Linux environment. In a Linux environment, GCC is the popular, GCC is the free compiler and also command based compiler. I hope H3 you got an answer. Same code if you compile in another compiler, same code if you compile in another compiler, you may get an error also. And one more important reason why we need to go for a GCC only. Why? Because in this command based environment, we can explore more compared to the GUI based environment. Again, in a command based environment, we can explore more compared to the GUI based environment. That is the reason for freshers, for beginners, if you want to understand the things properly step by step, better option is GCC compiler. So what if we prototype inside the flower brackets about the print? One of your friend question is, observe your friend question, can I include this here? Answer is yes. But thing is, as per the procedure, see, no warning, no error. But thing is, as per the procedure, above the main only you need to declare the functions. As per the C procedure, above the main function only you need to do that. So what will be the answer? What header file contains? Again, what will be the answer? I'll write the question, I'll write the answer also. Question is what header file contain? Answer is, can you tell me what header file contains? Answer is, it contain predefined function prototypes. It contains predefined function prototypes. Example, stdio.h contain printf, scanf, etc. function prototypes. stdio.h contains printf, scanf functions prototypes. Example, string.h contains strlen, strcpy, etc. function prototypes. Now where the definitions are present, can you tell me where the printf function definition is present? Where the scanf function definition is present? Definitions are present in the library. Where the call is present, can you tell me where the printf call is present? Answer is, printf function call is present in our source code. Is this question is clear? What header file contains? Answer is, it contains the predefined function prototypes. Second question is, why should I include? Why we need to include header file before calling function? Why we need to include? Answer is, this is the answer. Answer is, as per the procedure, any function is calling, before that it should be declared above. Declaration purpose, it should be declared above. But our GCC compiler for basic Hello World program, if we don't include also, excusing us by showing the warning, and it is creating an executable file. Header file is linked with libraries. One friend is asking, A1 is asking header files linked with the libraries. Wait, you will get an answer very soon. A1, wait, very soon you will get an answer. Header file is different, libraries is different. I need to tell you. Header file is different. Suppose this is the stdio.h. All the declarations are present. And library, the name of the library is libc.so. This library is different. This library is different. All in this library, all the function definitions are there. In this header file, only declarations are there. In this header file, only declarations are there. In this library, definitions are there. Now, this library is present in lib directory. Little bit more clarity. Once we started with a little bit in-depth concept, you will get it. S3 is asking, sir, how to use a scanf function in Ubuntu? Again, S3 question is how to use a scanf function in Ubuntu. If you see this, in this, observe, in this program, I am scanning two integers. S3, anyway, still more we need to talk about a scanf, don't worry. But just for your clarification purpose, we need to use this proper format specifier you need to supply, proper address you need to supply. Proper format specifier you need to supply, and proper address you need to supply it. Anyway, in a little bit more, anyway, once we started with this, we'll discuss it. Data types, variables, we'll discuss it. Now the thing is, what is this main then? As you know, the building blocks of the C program is, the building blocks of the C program is a functions. And your C program should contain minimum of one function. Again, your C program should contain minimum of one function. What is the name of the function? Your C program should contain minimum of one function. What is the name of the function? MAIN. Now suppose if I write not main, now will you agree in my now what we'll do? Let's first delete the now tell me, only hello.c is there. Now will you agree in my present working directory only hello.c is there? In that hello.c main is not there. In that hello.c main is not there. Now let's compile the code. Will the compiler generates an executable file or not? Now tell me, is the executable file is generated? Is that executable file is generated or not? Is this executable file is generated or not? Answer is no. Now you may get a doubt, sir, is it a warning or is it an error? Very simple. After the type ls, if a.out came, we need to say that is a warning. Again, why you deleted a.out every time for new program? See, just to confirmation purpose, I removed this a.out. When we observe that hello is there, I compiled it. Now if you want to identify this is a warning or error, that is the purpose of removing this a.out file. Now tell me, if suppose this may be a warning, can I say a.out might have created here? If suppose that might have warning, will you agree a.out might have created there? But it is not a warning, it is an error. That is the reason a.out is not created. Okay, one of the friend is suggested one option, hyphen no start files hello.c. Observe, when I type hyphen no start files hello.c, if I use this option hyphen no start files hello.c, if I use this option, a.out is created or not? A.out is created or not? Hmm? Now let's see, do we get an output or not? I got a segmentation fault. Means I didn't get an output properly. Observe, I didn't get output properly. I got some segmentation fault. What I means to say you that, without main also we can write. For all of you, my request is compile this code in a CoCalc. Compile this code in a CoCalc and try to check it out. There you try to compile this code like this. What is that option? What is the option? cc hyphen no start files hello.c. cc hyphen no start files cc hyphen no start files hello.c. Again v19b be7 a5 is asking, sir, what is the return value and all other things? Don't worry about it. Still I'm getting a segmentation fault, but in some of the environment, in some of the GCC environment itself, you will get this output hello world is going to be printed. Again, in some of the interviews they will ask you, can you write a C program without a main? And observe the logical question, can we write a C program without a main? What will be your answer? Can we write a C program without a main function? Question is, can we write C program without main? Answer is, in GCC we can write, but at the time of compilation we need to use option called hyphen no start files. For example, cc hyphen no start files p1.c, and we can't give guarantee that program is going to execute or not, but we can compile it. We can't give the guarantee that program is going to execute or not. Again, can we write a C program can we write a C program using without a main? Answer is yes, we can write a C program without a main. But the problem is, problem is that depends upon the compiler to compiler. But better approach is write a main. One of your friend question is, what is this no start file? Answer is this is a option. Using this, you are informing to the GCC compiler that in my source code, main is not there. Still compile the code. Do we write C program without main function in a GUI environment? That's what I'm saying, A11. That's what I'm saying, A11. Try to check it out. Will it works or not? It's clear? In this command-based environment, in this command-based environment, it will work. It is a no start files, I think. What is the difference between the void main and int main? One question came. What is the difference between the void main and int main? Again, my request to B3, this is not the time to discuss what is the void main and int main. When the proper time comes, I'll discuss it. Once I started with the function concept, what is the meaning of void, what is the meaning of int, all the things we'll discuss it. See, some of the interviews, they will ask such type of question like, without main, can we write a C program? For that, this is the answer. And please try to cross check in your environment, is this hello world is printing or not? If that is the case, we'll check it in a just a minute. We'll check it in CoCalC. I'm opening this V20 project. In this, opening this terminal. I'm writing this code. Again, don't confuse the void main into main, unnecessary right now. For the time being, not required. Return 1 or return 0. Now the discussion is without main, right? If my discussion is without main, ABC. Now you'll agree in my source code, main is not there. CC hyphen no start files main underscore a dot out is there, dot slash a dot out, hello world came. Observe here, in this CoCalC GCC environment, hello world came. All of you are observing, hello world came and segmentation fault came. But in this environment, hello world not came. Let's what I'll do. I'll change the code into int. Again, in this environment, it is not working. But in this environment, all of you are observing hello world came. And don't think about void main, void int right now. Function return type right now. Don't think it. When the time comes, we'll see. So why I discuss this point? You may get a doubt. Why I discuss this point? Answer is very simple. In some of the interviews, they will ask, can you write a C program without a main function? What you need to say, yes, in a command-based GCC environment, I can write a program without a main, but only the thing is, we can't give the guarantee the program is going to execute or not. And also, we can't, you need to compile the code using hyphen no start file. You need to compile. You need to compile with hyphen no start file. What is the spelling? GUA, whatever it is. Is this clear? Now let's conclude till now whatever we discussed it. After that, we'll move to the next topic. What is the header file contains? Header file contains prototypes, predefined function declarations. One of your friend sent one question. Sir, what is the exact work of this command? What is the exact work of this command? Using this command, we are informing to the compiler, without main, in my source code, main is not there. Even though main is not there, create an executable file. Again, using this command hyphen no start option, no start files option, we are communicating with a GCC compiler and saying that in my program, what is it? Saying that in my program, main is not there. Even though main is not there, compile my program. Now tell me, if I might have not written this and main is not there, what happens? If I might have not written the option no start files, sorry here, it is a no start files. Now tell me, if I have not mentioned the no start files option and in my program main is not there, then what is the scenario? What is the situation? Yes, K11 is saying that error. Is it clear? What is the error? What is the type of errors? Anyway, we need to discuss it. Better this discussion, we need to stop here. We should not prolong this discussion because there are so many other concepts are also related to this. At a time, you can't understand it. Next discussion is compilation stages. Next discussion is stages. Now, what is the meaning of compilation stages? Try to observe. Normally, what we'll do after writing the C program, we'll agree you'll compile this like this. After writing the C program, you'll compile the code like this. Yes or no? After writing the C program, you'll compile the code like this. Yes or no? Answer is yes. Now, what happens is when you compile the code, when you supply the code to this compiler, suppose this is the compiler. You're supplying the .c file. What it will generate? When you supply the .c file, can you tell me what it will generate? When you supply the .c file, can you tell me what it will generate? Will you agree it will generate a .out file? Now the point is, this compiler will not convert your program into mission understandable in a single step. Listen the statement very carefully. This compiler will not convert your program into mission understandable in a single step. Your program will undergo 4 steps. Again, your program will undergo 4 steps. Again, I'll draw it. When you supply the program to the compiler, input is a .c, output is a.out. Internally, your program will undergo 4 stages. Your program will undergo 4 stages or 4 steps. Now we need to understand those stages are called as a compilation stages. First stage of a compilation is preprocessor. Second stage of a compilation is translator. Third stage of a compilation is assembler. And the last stage of a compilation is linker. Is it clear? What is the discussion we are going to do? Again, is it clear what we are going to discuss now? When we supply a code to the compiler, my program will not convert into executable code in a single step. My program will not convert into executable code in a single step. My program will go into 4 different stages to get an executable code. Those stages are called as compilation stages, or I can call as a compilation steps. What is the first compilation stage? What is the first stage of a compilation? Preprocessor. What is the second stage of a compilation? It is a translator. What is the third stage of a compilation? It is an assembler. What is the last stage of a compilation? Fourth stage, linker. You may get a doubt. Is these stages in this order only? You may get a doubt. Is these stages in this order only? Answer is yes. Answer is yes. One very simple question, very logic things, try to answer it. How many of you watch Discovery Channel? Please let me know how many of you watch Discovery Channel in your TV. Okay, in that Discovery Channel, how many of you watch any product manufacturing episode? Product manufacturing, like what if you take chips are there, Lay's chips are there, or car manufacturing, or food products manufacturing, or mango juice manufacturing, or anything. So in that they'll explain you the procedure. First step, what is that? Second step, what is that? Third step, what is that? After how many steps the product will come into your hand? All these things they will explain it. Will you agree? Here also the same thing. When you supply the C code to the compiler, don't think that in a single step it is going to convert into a.out. Don't think that in a single step it is going to convert into a.out. To convert into a.out, there are 4 steps will be there. There are 4 stages will be there. Those stages are called as a compilation stages. That's what we are going to discuss now. Is it clear? First stage of a compilation is called as a preprocessor. Second stage is called as a translator. Third stage is called as an assembler. Fourth stage is called as a linker. Now, what is the job of each stage? We need to discuss it. What the preprocessor will do, what the translator will do, what the assembler will do, what the linker will do. We need to discuss it. Can we say that if we compile the code, like on the command prompt cc p1.c, internally all the stages are done, all the stages are done, and we will get executable file, and we will get executable file. So when we compile the code like this, my program will undergo these many stages and we will get an executable file. Now we need to understand each stage, what it will do. What is the first stage? Can you tell me what is the first stage? What is the first stage of compilation? First stage is preprocessor. What it will do is it will include header files. What is the job of the preprocessor? It will include the header file. It removes comments. It replaces macros. It will do conditional compilation. This is the main purpose. This is the main duties of the preprocessor. Preprocessor will include the header file. Preprocessor will remove the macros, remove the comments. Preprocessor will replaces the macros. Preprocessor will do the conditional compilation. Now, what is the macro and all other things at this stage? You no need to worry. I hope some of you may know that hash define pi as a 3.14. Have you heard this hash define keyword? So now what the preprocessor will do, this is called as a macro. Wherever this is there, it will replace with this. Now in detail of the macros, in detail of the preprocessor, at the end of the C program, anyway, we need to discuss it again. In detail of the in detail of the preprocessor, at the end of the things, we need to discuss it. What is the conditional compilation? What is the purpose? What is the use? All the things. But these two we can understand for the moment. For this moment, at this particular level of understanding, you can understand these two. And the command is cc hyphen capital E p1.c hyphen o p1.i. Again, the command is to do the preprocessor stage cc hyphen capital E p1.c hyphen o p1 dot hyphen o p1 dot I. Let's see. I'll discuss these points once again. Don't worry. Rm a dot out, rm hello dot c. Now will you agree? I deleted all the files. Will you agree? I deleted all the files. Okay. Now let's write newly one file p1.c stdio.h void main. Let's write a single line comment. And let's write printf hello world. Which header file I'm including here? Can you tell me which header file I'm including here? Will you agree I'm including stdio.h? Now, I don't know how many of you know, if want to come out from this VI editor, there are two methods are there. One is escape shift colon WQ. To come out from this VI editor, there are two methods are there. One is escape shift colon WQ, and another method is escape shift ZZ. Again, to come out from the VI editor, there are two methods are there. One is normal method is escape shift colon WQ. Another method is escape shift ZZ. Shortcut method is escape shift ZZ. Is it clear? CD is for changing the directory. Here we are not changing the directory. We are coming out of the VI editor. O1. CD is for changing the directory. Here our aim is not to change the directory. Our aim is to come out from the VI editor. Now observe CC hyphen capital E P1.C hyphen O P1.I. Observe CC hyphen capital E P1.C hyphen O P1.I. Now observe, think and tell me who created this file P1.C. This P1.c is created by us, correct? Who created this file P1.I? Who created this P1.I? Answer is preprocessor. Try to note it down this point. CC space hyphen capital E space P1.C space hyphen O space P1.I. Now let's open the .I file. Input for the preprocessor is a .c file. I'll write it here. Input for preprocessor is .c and output is .I. That's what .I extended C code. These are some extensions. Input for the preprocessor is a .c file. Output of the preprocessor is a .I file. Input for the preprocessor is a .c file. Output of the preprocessor is a .I file. Hyphen E means you're informing to do the pre-processing. Hyphen E means you are informing to the compiler, do the pre-processing. Now you tell me, if you might have not written this, can I say compiler will do all the stages at a time? If you might have not written that option, will you agree the compiler will do all the stages at a time? Now we are analyzing step by step. We are trying to discuss what internally the step 1, step 2. That is the reason this. Now observe, if I open vi p1.i, if I open this, observe it. Observe, all of you are observing this. How many lines are there? Observe. Are we written this much of big code now? Are we written this much of code now? No, right? How can I say preprocessor is included this header file content into our .I file? Preprocessor is included. See scanf function prototype. All of you are observing scanf function prototype, like this printf function prototype will be there. Observe, the code is increasing 600 lines, 700 lines. See, at the end our code is there. At the end our code is there. And also, have you observed here comment is removed? I hope you might have remembered or not, in a .c file one comment is there here. Now this dot I file is also called as pure C file. I need to tell you one point. This dot I file also called as pure C file or extended C file. This dot I file, and don't worry about these 2 points. Now this is not the time to discuss these 2 points. Now as simple as I'm trying to discuss it, later once again, once we started with the preprocessor at the end of the C program, again in detail we need to discuss it. So what is the input for the preprocessor? What is the input for the preprocessor? Dot C. What is the output of the preprocessor? Dot I. And again, what is the meaning of hyphen O? Meaning is dump this output into this file. The output of this will go to this file. That is the meaning of hyphen O. Now can you tell me what is the input for the translator? What is a pure C code, extended C code? That's what it is ready to translate. It is ready to convert. P2. What is the meaning of pure C code? Means it is ready to translate or it is ready to convert. Is it clear? Input for the translator is .I file. Output of the translator is .s file. Again, next stage is, second stage is translator. Input is .I file and output is .s file. And what it will do? It will check what the translator will do. Translator will check syntax errors. Translator will check the syntactical errors. It will convert C code into assembly code. It will convert the C code into assembly code. So translator main job is, it will check the syntactical errors. What is the syntactical errors? Everything will check it out. And it will convert the C program into assembly program. Command is cc hyphen capital S p1.s p1.I hyphen o p1.s. The command for translator unit is, translator stage is cc space hyphen capital S space p1.I space hyphen o space p1.s. Now let's check it out, this command here. Again, these are the options. There is no specific meaning. Hyphen S is you're informing to the compiler to do the translator stage. S9, got the thing? There is no specific meaning for that. That is hyphen S p1.I hyphen o p1.s. Now observe, who created this .s file? Can I say translator is created this .s file? Who created this .s file? Answer is translator is created this .s file. Who created this .i file? Answer is preprocessor is created this .i file. Who created this .c file? Answer is we created this .c file. Now let's open p1.s. Observe, our C code is converted into like this assembly code. Observe, our C code is converted into like this assembly codes. I hope all of you might have remembered some assembly instructions, push instruction, pop instruction, RET instruction, move instruction. All of you are observing this code. So translator did this job. Translated this did this job. It is converted our C program into assembly. Now my question is, assembly code is a hardware understandable? Yes or no? Assembly code is hardware understandable? Yes or no? Answer is no. Assembly code hardware will not understand. Op codes it will understand. Mission understandable code it will understand. Assembly code is still human understandable code. Will you accept? Assembly code is still human understandable code. Is it clear? Huh? Add instruction, move instruction, hardware cannot understand. You know that hardware understands the binary code. Huh? You know that hardware understands the binary code. Next stage is what is that next stage? Third stage, assembler. The job of assembler is input for the assembler is input is .s file and output is .o file. Input is .s file and output is .o file. The job of the assembler is it will convert assembly code into mission code. It will convert assembly code into op codes. I can write it. It will convert the assembly code into op codes. S5 is saying that in my terminal, after compiling the .s command, it is showing that command not found. My question to S5 is .i file is there? My question to S5 is this .i file is there? Is this .i file is there? S5, please reply it. Now, yeah, are you used capital S or small s? Have you used capital S or small s? Capital. Have you given the space between this? Have you given the space between that S5? Have you given the space between that? CC space -s space p1.i space -o space p1.s. Now you check it out. CC space capital S space p1.i space -o space p1.s. Now you check it out. One of your friend is saying that what is an op code? I don't know if you might have worked on the microcontroller or microprocessor. every instruction, there is a operational code will be there, which is in a hexadecimal. Every assembly instruction, there is a opcode will be there, operational code. That opcode, you need to dump it into the microcontroller, not the assembly code. Assembly code still hardware cannot understand. A9, if you want, you can download the datasheet of 8051 microcontroller. You will get it. Or if you already knows about the microprocessor, microcontroller, I think you may know it. S5, I'm still waiting for your answer. Got the things? S5, I'm still waiting for your answer. Yes. Now observe what this assembler will do. It will convert our assembly code into opcodes. And after assembler stage, what is the output we are getting? .o file is called as object file. .o file is called as object file. object object file. Now observe, let's see the command. I might have not written the command right. Command is cc hyphen small c p1.s hyphen o p1.o. Again, the command is cc space hyphen small c space p1.s space hyphen o space p1.o. Let's check the command cc space hyphen small c. I'm stressing the point small c, but have you observed previously two are capital? Previously two are capital, now it is a small. cc hyphen small c p1 dot small c p1 dot, just a minute, p1 dot s hyphen o p1 dot o. Now observe, this is my source code, this is the preprocessor output, this is the translator output, this is the assembler output. Can I say this code is a mission readable code, not a human readable code? If I open p1.o, I can't. See, you can't understand the things. Huh? Able to see some unknown format. My very simple question to everyone, how many of you opened exe file, right click open with editor? Suppose you are working a Windows environment. If you any exe file is there, just right click open with any editor, you will observe such type of code only. You will observe such type of code only. Binary code. Is that point is clear? That is not a human readable code. And also, how many of you know it? Editors will support only ASCII text file. Editors via editor or any editors will support ASCII text file. You can see only the text file. You can't read the, you can't open the executable file. You can't see the content because that is not an ASCII file. That is a binary file. That is not a human readable file. Again, editors will support only ASCII text file. So what happens till now? Till now, your program is converted into mission understandable code. After the assembler, your code is converted into mission understandable code. Now you may get a doubt, then what is the job of a linker? Observe, linker job is, observe, linker job is to convert to add, sorry, linker job is to link with library to add OS information and create executable code. Again, linker is responsible for linking with the libraries because printf, scanf function definitions are there inside the library. So linker is responsible for linking with the libraries. Linker is responsible for adding the operating system information into it, OS information into it, and linker will create an executable code. One thing, executable code is a code on the top of the OS it will execute. Executable code is a code on top of OS it will execute. Executable code is the code on the top of the OS only it will execute. Without OS it will not execute. And raw, there is a term called raw code is a code without OS it will execute. A raw code is a code without OS it will execute. I don't know, you may know it or not. When you supply a C program to the Keel software, it will create .exe file. Sorry, .hex file. Do you know the things? When you supply the source code to the Keel compiler, what it will do, it will convert into hex file. Have you heard the term hex file? Anybody heard? Anybody know the term hex? Now this hex file, you need to dump it into the microcontroller. This hex file, you need to dump it into the microcontroller. Now tell me, in this microcontroller, OS is not there, but still it will execute. In that microcontroller, OS is not there, still it will execute. That is called as a raw code. A raw code is a code without OS it will execute. Executable code is a code with OS it will execute. So what the linker will do? Linker will link with the libraries. Linker will add OS informations and create an executable code. The command is cc p1.o. The command is cc p1.o. Now observe cc p1.o. Sorry. Now what is the executable file name it is created? What is the executable file name it is created? What is the executable file name it is created? A.out. All of you are observing? A.out. Please reply to my question. All of you are observing this A.out? Now observe diagrammatically. You need to write ./a.out to see the output. Correct. Case 6, you need to write ./a.out you need to get the output. Observe, we are supplying the .c file to the preprocessor. It will create .i file. That .i file we are supplying to the translator. It will create .s file. This .s file we are giving to the assembler. It will convert .o file. This .o file we are giving to the last stage is a linker. Then it will create an A.out file. Is there any command to link? That's what when you write cc, this is a linker command. N3, this is a linker command. It's clear. Now tell me, I don't want a dot out, I want any other file -op1. You don't, if you don't want a dot out, if you want separate file, you go for -op1. So preprocessor has its own duties, translator has its own duties, assembler has its own duty, linker has its own duty. Now tell me, who will include the header file? Preprocessor. Who will link with the libraries? Who will link with the libraries? Linker. Who will convert your C program into assembly? Translator. Who will convert your assembly program into opcodes? Assembler. If all these stages are done successfully, then only the a dot out is going to be created. Again, if all these stages are done successfully, then only a dot out is going to be created. Got the point? If all these stages are done successfully, we can open this, we can open this, we can open this, but we can't open these two because those are not in a ASCII text file. These are binary file. So we can't open p1.o, we can't open a.out. If you open it, we can't see the content. R3, got the point? These are not a ASCII text file, those are the binary files. Okay, so what I'm going to do is I'm going to share this file to you immediately after the class as usual. Just go through this. If any doubt is there, tomorrow we'll start with a doubt session, doubt things. Is it clear? And after that, tomorrow we need to talk about an errors: compile time preprocessor error, compile time translator error, compile time linker error, runtime errors. All these stages will be done by the, when you use like this, again I'm typing here, when you write cc p1.c, internally my program will undergo all these stages. S5, when you compile like this, my program will undergo all the stages. If you want to do manually, this is the thing. First you do the preprocessor, next you do the translator, next you do the assembler, next you do the linker, step by step if you want to do. If you don't want step by step directly, you may get a doubt, what is the use of step by step compilation? That you will get in a later, in a tomorrow's lecture we'll get it. Why we need to go for a step by step. Got the thing? S5, got the point? Okay. So thank you very much for attending. Tomorrow we'll continue with this. I'll share this immediately after the class in a Moodle. Thank you very much. I'm going to stop this meeting.